Hi there. We are going to do Learning Target 5.6 today. It's the last one in Unit 5. We didn't have time to get it in before the test, before Christmas break, but it's a great review because it's asking you to graph these lines, and then it's and after you graph them, we are going to use the fact that they're inequalities. So when you graph lines, those are equalities. Y equals 5x plus 2, or y minus 7 equals 3 times the quantity of x plus 3, depending on what formula you have. We, so far, up till today, have graphed in the coordinate plane equalities. Now we're going to be graphing inequalities. And with an inequality, there are several different things that a value can be. For instance, if I just wanted you to graph x equals 5, x can only equal 5. So every point on that line would just be where x is 5. If instead I wanted you to graph x is greater than 5, then I'm going to graph every single number that's bigger than 5. X could be 6 or 7 or 8 or 9 or 1,000 or 2,000 or 5,400, right? So when we graph inequalities, we have a lot of other options for things that would make this inequality true versus just an equality, which is why we have to shade it. In order to graph inequalities, there are 3 main steps. And again, if you can't see this because it's a little bit blurry through the video, this is a PDF that's uploaded to Google Classroom. Look at that PDF. Better yet, print it off so that you have it. All right. If you don't have the ability to print it, please look at the PDF and write this information in your notes. So the first step is to get the inequality into slope-intercept form. All right. This is already in slope-intercept form for us. Remember that means that we solve for y and then have everything else on the other side. Once you do that, you're going to plot the y-intercept. Remember that this constant is the y-intercept. So here it's already in slope-intercept form. If I plot the y-intercept, my y-intercept is 3. So I put a point at 3. And then I use the slope to count rise over run. Remember that the slope is the number that's multiplying x. So here my b is 3. My slope, which is m, is 1/2 because 1/2 is multiplying x. So from my y-intercept, I'm going to count rise over run. So I count up 1 over 2 because that's what my slope is. Right? So it just says plot the y-intercept. I did that. Use the slope to plot another point. I've done that. Now, usually, if we were just graphing an equation, we would connect those points with a line and be done. Now we're plotting and graphing inequalities. So when you graph the boundary line, because it's going to be anything greater than or anything less than, depending on our inequality, I have to follow this rule. I'm going to use a solid line if it's an equality, an inequality that's equal to. I'm going to use a dotted line if it's less than or greater than. This right here is telling me that it's going to be a dotted line because it's not equal to. It's just greater than. So when I connect these, I'm using a dotted line to graph that boundary. And then the arrow in both directions, right? That's a change. If it was an equation, I would draw a solid line and be done. It's a dotted line because it's greater than. The third step is to select a test point and determine which side of the boundary line should be shaded. If it was right on that line, it would be equal to it. Now I'm trying to decide which values of y make it greater than. Are they the values that are on this side, or are they the values that are on this side? So in order to decide whether I'm going to shade under the line or over the line, I'm going to pick a test point and see if my test point makes my equation true. Now you can use any test point that you want, but it can't be on the line. My suggestion is to use 0, 0 as your test point every single time unless your boundary goes through 0, 0. If it goes through 0, 0, that would just tell you whether it was equal to it, not whether you needed to shade towards it. But as long as your boundary line doesn't go through 0, 0, then you can use 0, 0 as a test point. And 0, 0 is really nice because multiplying by 0 clears out the values. So I'm going to check and test that point. When I test 0, 0, what that means is I'm putting a 0 in for y, because y is 0, is greater than 1/2 times 0 plus 3. So I put a 0 in for y, I put a 0 in for x into this inequality. I want to see if this is true. Well, half of 0 is 0, plus 3 is 3. So this is saying 0 is greater than 3. Is that true? No, 0 is not greater than. So it's false. My test point was false. Right? And that's when it says here, if the test point makes the inequality false, which it did, 0 is not greater than 3, then I'm not shading towards 0, 0. I'm shading the other half. So my boundary splits my plane into two parts. I have this part, I have this part. 0, 0 is in this part. If it would have made that true, then I would have shaded towards 0, 0. But it makes it false, so I'm shading the other part. So I'm shading up here. And any point that's in my coordinate plane up here will make my inequality true. And that's the graph of y is greater than 1/2 x plus 3. Right? Again, 3 steps to do this. You're going to get the inequality into slope-intercept form. We're going to graph the boundary line, make sure that you know the difference between dotted and solid, and then we're going to select and test point and shade. All right, let's try this one. We have to first get it into slope-intercept form. So slope-intercept form says that our x has to be on the other side. So I'm going to subtract 3x. That leaves me with negative y is less than negative 3x plus 2. Well, this isn't slope-intercept form because my y is negative, right? Don't forget that if I need to get my y to be a positive and I have to divide by a -1, then when I divide by that -1, my sign flips. So then I get y is greater than 3x minus 2. Because each of those terms get divided by that -1. And this is what I have to plot. So my b will be -2. My slope will be 3. Okay. So here's my b at -2. Rise over run is up 3. 1, 2, 3 over 1. Is my line going to be dotted or solid? Well, this right here tells me that it's dotted, because it's not equal to. So when I do this boundary line, it's dotted. Okay. And then the next and final thing is to test. It doesn't go through 0, 0, so that's an okay test point to use. I can put 0, 0 into this, or I can put 0, 0 into this. I just have to decide where I put it in, does it make it true? So if I put it into here, if 3 times 0 minus 0 is less than 2. So I get 0 is less than 2. Is 0 less than 2? And yes, 0 is less than 2. So it's true. When it's true, I shade towards 0, 0. So here's 0, 0. That means that I'm shading on the side of the line where 0, 0 is, which is over here. And you can do this with a pencil. I'm just using a colored pencil because I like color. Okay. So any point that's on this side of that boundary line will satisfy and make that inequality true. Okay. It's all the way up to that line, but not including that line because it's not equal to. Okay. And this one, this is actually in slope-intercept form because the y is solved for. Right? Another way to think about that, if you really do like the y on the left-hand side, I have a y and I have an x minus 1. My alligator mouth is opening toward the x minus 1. So if I switch these around, I've still got to switch. When I switch around and put the x minus 1 on the right, I've got to still make my alligator mouth eating that one. Right? So then my m, what's my m here? 1. What's my b? 1. So when I graph this, -1, and then my slope up 1 over 1, is it going to be dotted or solid? It's going to be solid here because it's equal to. I'll make my solid boundary line. Next step is to put 0, 0 in. If I put 0, 0 in, I get 0 minus 1 is greater than or equal to 0. So when we test 0, 0, you're just putting a 0 in for x and a 0 in for y and seeing if it makes it a true statement. So this is -1 is greater than or equal to 0, which is false. So if it's false, I shade on the side that's on the other side of my boundary from 0, 0. So here's 0, 0. I want to shade away, so I'm going to shade on this side of it. The shading is critical to graphing inequalities. Right, over here, we have to put it into slope-intercept form. Go ahead and do that. What is slope-intercept form here? Well, if I subtract x, I get -x plus 10. When I divide by -5, remember that dividing by a negative flips it. So I get y. This flips. -x over -5 is 1/5 x. Right? That's understood to be a 1 there. A negative and a negative make a positive. 10 divided by a -5 is a -2. So my y equals mx plus b form will be y is greater than or equal to 1/5 x minus 2. My slope is 1/5. My intercept is -2. Right, so I plot that, -2, and then up 1 over 5. Is this going to be dotted or solid? Well, if you look here, it's equal to, so it's solid again. That's the part that tells us that. So I'll do a solid line. My test point, if it's not going through 0, 0, use 0, 0 as a test. Again, you're putting 0 in for both the x and the y. So I get 0 instead of this x, minus 5 times 0 is less than or equal to 10. When I simplify this and see if it's true, is 0 minus 0 less than or equal to -10? Yes, it's true. All right. So will I shade in 0, 0? Yes. So here's 0, 0. I'll shade that in. And it's up here. Everything on this side of the line, including the line this time, is a solution to that inequality. When we were graphing here, we were using y equals mx plus b, and we had a numeric slope. Remember that we can also graph horizontal and vertical lines. Remember that if it's a horizontal line, it will only have y variables, and it will be like this. If it's a vertical equation, it will only have x variables. Flux goes up and down. So then everything else holds from what we were talking about up here. You're still going to look at dotted versus solid if it's greater than or less than versus greater than or equal to and less than or equal to. You're still going to look at picking a test point of 0, 0 and seeing if it works. If it works and it's a true statement, you shade in that direction. Okay. So for y is less than 4, what does this symbol tell us? Well, that symbol tells us it's going to be a dotted line. Because it's only a y, this y tells us that it's going to be a horizontal dotted line. Because of that always horizontal. All right, so I'm putting a horizontal line through 4, and it's dotted because it was just less than. There's my boundary. My test will be 0 for the y. So if I put 0, is 0 less than 4? Yes, it's true. So when it's true, I shade towards 0, 0. And that's what you get. You do this one. What does your answer look like? Well, this is telling us that it's a box, so it's vertical. This here is telling me that it's a solid line. So I'm going to put a solid vertical line through -2. Go. If we test, put the 0 in for x, is 0 greater than or equal to -2? Yes, it's true. So again, I'm shading towards the 0, 0. Here's 0, 0, so it's that on the right-hand side of our boundary line. If you skip the shading, your answer is not true. That's not a good graph. Every time that you have an inequality, you will have to shade. All right, so shading and test points are new to graphing inequalities. Everything else should have been a review. All right, reach out if I can help you at all, and I'll see you next time.